In this video, we're going to be solving a static equilibrium problem in 2 dimensions involving a suspended weight. In this example, a 200 kilogram mass is suspended, and we need to find the forces in the links given in the diagram. The first step is to calculate the weight. So at the moment, we have the mass, which is 200 kilograms. We need to convert this into a force, so multiplying the mass by gravity. So the weight W equals mg, which is 200 times 9.81 newtons per kilogram. Therefore, the weight is 1,962 newtons. We can represent this on the diagram as an arrow pointing downwards from the point O. So converting the diagram into a free body diagram, we're going to replace those chains with arrows representing the forces in those members. So the next step is to resolve those forces. So if I bring that red arrow down for FOA, I want to resolve this into a vertical and a horizontal force. So we know that the angle within this is 40 degrees because all of the angles in the triangle add up to 180. We'll start by finding that horizontal component of the force. So this is next to the 40 degrees, so it's the adjacent, and the FOA is the longest side, the hypotenuse. Since it's a right angle triangle, we can use trigonometry, and we know that the relationship between the adjacent and the hypotenuse is cosine. So we can rewrite this horizontal force as FOA cos 40. Similarly, we can resolve that vertical component. So that vertical force is opposite that 40-degree angle. And again, we know the hypotenuse, the longest side, is FOA. So we can rewrite that opposite side as FOA sine 40. And then we can resolve the other arrow FOB. So if we bring that one down as well, we want to rewrite this as the sum of a vertical and a horizontal force. So this time the angle using the rule of Z angles is 30 degrees. So we're going to start by resolving that horizontal force. So this side is next to the 30 degrees, so it's adjacent. And again, we know the hypotenuse is FOB. So we get that this horizontal force is FOB cos 30. And then we can work out that vertical force. So this side is opposite where the angle is. So we get that this vertical component is FOB sine 30. Because the system is at equilibrium, the sum of the forces is 0. This means that the sum of the horizontal forces is 0, and the sum of the vertical forces is also 0. So taking the sum of the horizontal forces, we take the forces to the right as positive, and forces to the left as negative. So the forces which involve a component going to the right is the FOB, and we said that that horizontal component is FOB cos 30, so we'll get plus FOB cos 30. The FOA has a horizontal component in the left direction, and because this is going to the left, it's going to be negative. And we said that that horizontal component is FOA cos 40, so we get minus FOA cos 40. And since the other force doesn't have a horizontal component, the sum of these horizontal components is equal to 0, which gives us our first equation, FOB cos 30 minus FOA cos 40 equals 0. So what we can do here is we could rearrange this in terms of FOB. So adding the FOA cos 40 to both sides, and dividing by the cos 30, we get that FOB is equal to FOA multiplied by cos 40 over cos 30. So taking the sum of the vertical forces is 0. So by convention, taking the upwards direction as positive, the downward direction is negative. So the only arrow which points upwards is the FOA. So it means that the vertical component is going to be positive. And we've worked out that vertical component is FOA sine 40. So we get plus FOA sine 40. Then look at the forces going down. So that FOB is going down and to the right. So that vertical component is going to give us minus FOB sine 30. And we also have the W going down, so that is minus 1962. And we know that the sum of the forces in the vertical direction equals 0. So this gives us our second equation, FOA sine 40 minus FOB sine 30 minus 1962 equals 0. So we now have simultaneous equations, and we can solve this to find the forces FOB and FOA. So taking our equation from step 3, FOB equals FOA cos 40 over cos 30, and we can substitute this into the equation that we've just got. So rewriting FOB as FOA cos 40 over cos 30, this gives us FOA sine 40 minus sine 30 cos 40 over cos 30 is equal to 1962. So everything in the brackets is just a fixed number, so we can divide by that number, and this gives us that FOA is 9,785 newtons. And we can put this back into our equation from step 3, and we get that FOB is 8,655 newtons. So we found all of the forces in those original links.